Let's continue our discussion on evaluation metrics. By the end of this topic, you will be able to interpret and explain the AUC-ROC curve. AUC-ROC curve is a performance measurement for classification problems at various threshold settings. AUC refers to the area under curve and ROC stands for receiver operating characteristics. Higher the AUC, the better the model is at predicting zeros as zeros and ones as ones. The terms AUC-ROC, ROC and AUC can often be used interchangeably, so don't get confused. In other words, the higher the AUC, the better the model is at distinguishing between zeros and ones. For example, in our cancer dataset, higher the AUC, the better the model is at distinguishing between patients with disease and no disease. But before we dwell deeper, we need to keep in mind that AUC-ROC only works well for nearly balanced datasets. AUC-ROC is not suitable for the cases where there is an imbalance in the nature of the class frequency. The ROC curve is plotted with TPR against the FPR, where TPR is on y-axis and FPR is on the x-axis as shown in the chart shown on the screen. Don't worry right now about what is FPR and TPR. We will discuss them shortly in the video. But how is this graph prepared? The graph is prepared by calculating values of FPR and TPR at different threshold values and plotting them together. Let's first discuss what FPR and TPR are. FPR is false positive rate and is the ratio of the prediction that were actually negative but predicted as positive to the total number of actual negative. As you can see, this is a ratio whose maximum value can be 1 when we predict all actual negatives to be positive. That is Tn equal to 0, and its minimum value is 0 when there is no false positive in our prediction. On the other hand, TPR is true positive rate and is the ratio of predictions that were actually positive and predicted as positive to the total number of actual positives. Like FPR, the value of TPR can be 0 and 1. So on the x-axis we have the FPR values and on the y-axis the TPR values. We know that the FPR and TPR values range from 0 to 1. So you can imagine this as a box of size of 1 by 1 area. Therefore, its area will be 1 unit. This is pretty important to keep in mind, as in the ROC curve we generally talk about in the terms of area under the curve. Now we know what AUC-ROC is and what FPR and TPR are. Let us now look at how AUC-ROC curve is constructed. For that, we will consider this sample data that we have prepared. This data comprises the actual values and the predicted probabilities. Now, we said that to prepare AUC-ROC curve, we need to calculate FPR and TPR for different threshold values. So should we try every value in the range 0 to 1 as a threshold? That's not really practical, right? Instead, we can set each of these predicted probability values as a threshold and generate the TPR and FPR. First, we need to arrange the predicted values in descending order. Then, we take the first value as a threshold and the classes as predicted based on this threshold. Once this is done, we can calculate the TPR and FPR values. So these three steps will give us one set of TPR and FPR for the first threshold. We can repeat these steps for the next value. We predict the classes by taking 0.9 as the threshold. Similarly, here are the classes for a threshold of 0.78, 0.56 and so on. In each case, we will get a set of TPR and FPR values. The TPR and FPR values can be calculated for all the probabilities. Based on these values, we can come up with a plot, the ROC curve. Once we get a plot like this, then the area under this curve can be used to determine the performance of the model. As we said, higher the AUC-ROC, better is the performance of the model. However, if the AUC-ROC is greater than 0.95, there could be something wrong with your model or dataset, and you should check it thoroughly. Pretty awesome, right? Now in the next video, we will be looking at the implementation of the logistic regression. See you then.